Moving on to the last part of measurement and resistance. The topic we are going to start is measurement of high resistance. Okay, the methods used here are loss of charge method, direct deflection, Megger and mega Ohm bridge. Okay, first we are going to study loss of charge method. Okay, high resistance means you are trying to find out resistance of an insulator. Okay, as we have studied in part 1, a high resistance is something that has resistance greater than 100 kilo ohm. Okay, so we are trying to find out, basically we are trying to find out the effectiveness of an insulator, okay, through this method, through these four methods. Okay, first we are going to study loss of charge method. Okay, this is the particular circuit you have to keep in mind. Okay, what we are doing here is it is loss of charge. Okay, we are allowing this capacitor to be charged. Okay, we are closing the switch and completing the circuit, and there will be some certain amount of charge stored in this capacitor, and then what we are going to do is we are turning it off and allowing this capacitor to discharge. Okay, then the voltage across a capacitor at particular time t is given by this formula, and tau here is the time constant given by RC, and this is the graph. Okay, the loss of charge graph. Okay, the loss of this is actually the voltage across capacitor. Okay, and to that of time. Okay, then we are having insulation R to be measured is parallel to C. Here you can see it is parallel to capacitor. Here this is your unknown resistance. Then C is allowed to charge and discharge. Voltage across capacitor at particular time is given by this formula, and your unknown resistance is given by either this formula or this formula as per the demand of the question. And then we have Megger. Okay, it works on an electrodynamometer principle. Here current creates torque and permanent magnet causes some flux. Okay, and deflection in coils are proportional to resistances. Okay, so and so forth. So what we are doing, this is your actually connection you have in mind. Okay, here currents are causing some flux and magnet is causing flux and current is creating some torque. Okay, these things is happening over here. So your current coil and pressure coil are facing some deflections, and based on these deflections you are able to calculate the unknown resistance. Okay, this is what we are going for. Here you can see this is the analysis over here, and here you know that theta is proportional to the unknown resistance. Okay, we are having this proportionality relationship, okay, with that of this deflection angle and that of your unknown resistance. Okay, then the advantage of this method is it is portable, it has hand driven generator, so no need of supply, it is used as insulation tester, and it is mostly used. Okay, then we have insulation of cable, transformer, bushing insulation and winding insulation. Then we have direct deflection method. Okay, a sensitive galvanometer of D arsenal type is used in place of micrometer. Okay, high voltage small current insulator. Okay, then we have cable without metal sheath can be also be tested. This is your circuit. What you are doing here, you are having your conductor, and this is the insulator. Okay, insulating material, and this is your metallic sheath, and what we are doing is we are trying to find out the leakage current. In order to find the resistance of this particular circuit, you are already knowing what the voltage is. Okay, we are giving it a particular supply, and we are supplying here we have attached the galvanometer. Okay, the leakage current and the voltage will let you know the resistance of this insulator, and this is what we are going for. Here this is your guard wire and stuff. You need to keep in mind the particular diagram. Okay, here galvanometer or microammeter is used. Why microammeter? Because you are testing out the effectiveness of an insulator. If an insulator is effective, you know very small amount of current in some micro amperes will be flowing through it, and a normal ammeter will not be able to measure it, so we are using micrometer. And the last method what we are having is the mega ohm bridge. Okay, this is your bridge over here, and this is the method we have addition over here. Okay, in this particular format, here RAB is the cable insulation. Okay, RAB is the cable insulation, and RAG and RBG are particularly your leakage currents. Okay, at balanced condition you have this particular formula, and RAB which is the cable insulation, what we are looking for, the unknown resistance value, is given by this particular formula over here. Okay, and these could be the case as the case may be. Okay, so this is all for measurement and resistances, and this entire sheet has been completed.